Okay, so let's get started. Uh, Alexis, can you do me a favor and read where it says Jesse?
Jessie is using a map to travel from her home to the state capital. She measures on the map to find the route is 4 inches long. The scale of the map says 1 inch equals to 20 miles. How could Jessie determine the number of miles she will travel to the state capital?
Okay, so they give us a very simple example, but they're not asking for the answers, but rather, how could she figure it out? So, any thoughts as to how she can figure this out? Yeah.
To what she can do will probably she could go on the map and she can measure how many inches it is to travel to the state capital and probably multiply the amount of inches that she had by 20
Mm-hmm.
and she'll get the amount of miles.
Yeah, and that's exactly what you would do, and it's using what they're trying to get us to say. It's use your proportional thinking, or let's say use proportional reasoning. So we're going to use proportional reasoning, which is what we were setting up when we were setting up ratios, and now we're going to use proportions with that. Um, so let's write this down. Finding a missing side length, which is one of the things we do with similar figures. Similar figures have corresponding side lengths that are proportional. Um, when two figures are similar, a proportion or scale factor, so write the word scale factor here, can be used to find a length of an unknown side. Um, so let's take a look at this example here. We have two triangles, A, B, C, and D, E, F. And let's say they're similar. Here's the symbol for similar, by the way, little tilde. So triangle, let's say triangle ABC is similar to triangle DEF. And the way I listed the letters is actually important because using that we can set up a proportion, a ratio. Grab a different color. So let's say I have AB. On our other triangle, which side corresponds to AB? DE. Okay. Now we want to find another pair of corresponding sides from both triangles that includes our unknown side. So I'm going to choose BC. And the reason I chose BC is it corresponds to EF. So now I could set up a proportion. And I could say, um, I could do it any number of ways. So let's call this unknown side X, our favorite variable. And I could say AB over BC. I could do it that way. So let's do that. AB over BC. So I picked the two sides that I identified here. And if I set that up correctly and proportional on the others for the other triangle, what would I want for the numerator? if I picked AB, DE, they have to, across the way, they have to correspond. And so that means EF would go here. Okay? So you just have to recognize an acceptable proportion, and that would work. Okay? So what I'm going to do now is replace everything with either a number or X. So AB I'm going to replace with 6. Let's replace BC with 8. And what am I going to replace on the other side? What am I going to replace DE with? 4. And so this would be X, because EF is X. And now it's a proportion. Remember how we saw proportions? A little cross multiplying. So when I do the cross product, what do I get? Multiply 6 with X. What is that? 6X equals 8 times 4. Okay. And now let's divide. And I already know this is going to be either a fraction or a decimal. Why don't we all figure out 32 sixths? Yeah, it looks like we got a repeating. So we can either write this as 5 1/3 or 5.3 repeating. So X is going to be 5.3 repeating. That's the length of EF there. Okay. Any questions? All right. So let's practice. Practice. Practice makes it permanent, as they say. Use your understanding of similar figures to answer the questions below. Okay, let's practice setting up some proportions. We're going to assume these trapezoids are similar. They want us to find the length of RS. So RS, let's figure out where RS is. RS is here. So this is our unknown. So since they are similar, I just like drawing that symbol for similar. We could set up proportions. Let's find some matching sides. What matches up with RS? What corresponds? Is it AD or BC? BC, the longer one. Okay. And which other side do we want to work with? Yeah, use the ones that you know lengths for, obviously. So we want AD, and that corresponds to QT. And now let's talk about the type of proportions we could set up, because that's always interesting. They have to be consistent. So take a look at the proportion I'm going to set up. I'm going to set up BC over RS. You see what BC over RS. I have to be consistent on the other one. Okay? So I chose one here and that one there, BC and RS. If I chose that, how do I have to set up the other fraction? Yeah, you have to do it that way. Depending on what you set up here, you have to be consistent for the other. So I chose this one over this one, which means I have to choose this one over that one, AD over QT. And that's acceptable. As long as you're consistent, you'll be fine. Any questions on that? Because That's the part that sometimes gets confusing. How can I set this up? Because if you notice before, I did two from the same triangle. I did AB over BC. I did this over this. So I had to do this over this. But here I did this one BC over RS and then AD over QT. That's also acceptable. Okay, let's replace this with numbers. So for BC, I want 2.8 over RS, which is X. And over here, what do we want? AD, 1.7, and then 5.1. Okay, so now let's do our cross product. We multiply X with 1.7 and 2.8 with 5.1. Okay, so go ahead and set up that equation. Set up the equation. X with 1.7. And then we're going to do 2.8 times 5.1.
14.28.
Yeah. Okay. And let's divide away the 1.7.
8.4.
Yes. So we get an answer of 8.4. So RS equals 8.4 meters. Okay. All right. So let's see what we get for this one. The perimeter of the triangle GHI is 40 centimeters. If the triangles are similar, again, they have to be similar. What is the length of JL? So the one we don't know is JL. That's going to be our unknown. All right. Take a look at the triangles, guys. We have an unknown side that we have to figure out first before we can even start setting up proportions. Look where JL is. What does it correspond with? GI. JL corresponds with GI. Do we know the length of GI? No, we have to figure that out. Let's go back to the fact that the perimeter, the distance all the way around is 40.
15 plus 15, and that's 30, and then 40 minus 30, and that equals 10.
So this is 10 centimeters. Because 15 plus 15 plus, well, let's say something equals 40. And if you do the math, it's going to be 10. Okay, so now we could set up a proportion. So that's what I would like you to do. We figured out this, set up a proportion, and find out what JL is. Okay? Maybe yours is different, but we should get the same answer. If you set up your proportion differently, you will still get the right answer as long as your proportion to begin with was correct. So I did GH over GI equals JK over JL. So that gives me 15x is 100. And if I answer this, if I divide by 15, I want 100 divided by 15.
6.6 repeated.
Yeah, 6.6 repeating. So you could say 6.6 repeating or 6 2/3. Either one is correct. So I'm running out of room to put my answer. Okay, I'm going to put it up here. JL is 6.6 repeating centimeters. Okay. All right. So hopefully you got 6.6 repeating. Okay. Um, so number three, giant triangle HJK is similar to triangle LMN. Bethany says there is more than one proportion that can be used to determine the missing side length, X. Do you agree? Is there more than one proportion? Yeah. We've done that before, right? I mean, we have to use this one and this one for sure because X is one of those. And then it just depends on what sides. You could pick 6 and 15, or you can pick 10 and 25. Okay, let me get a different color. Okay, green. So let's just write down a couple of proportions that would work. We won't necessarily solve them, but we could do 8 over x equals 10 over 25. Or, can someone give me a different one? It has to have 8 and x, of course. Yes. 8 over x equals 6 over 15. Or, here's a different one. 8 over 10 equals 6 over 8 over 10 equals x over, I'm sorry, that should be an x. I got a little, where is my, let me just put an x. 8 over 10 equals x over 25. That's just another one. Okay, and all of those would give you the same answer. Sorry about that. 6 there, it should be an x. Okay, all right. Let's talk about scale drawings. Okay. 2 and 3 dimensional objects can be represented with scale drawings or what's called a scale model. So write the word scale model, please. MODEL. So to give you some examples, we could say a map. A map is a scale model. A photograph. A photo. Believe it or not, shadows. That's going to produce. And then blueprints. Oops. So these are all types of examples that produce scale drawings. All right, so let's look at a few examples here. So it says the photo below will enlarge to form a, and this is the key, 16 by 20 inch print. What is the scale factor needed to enlarge it? So we're going to enlarge this to our new picture, and it's going to be 16 inches by 20 inches. And what they're asking is the scale factor. We've done this before, but let me refresh your memory. To find the scale factor, we'll just say SF. That's a common abbreviation for scale factor in math. we want the new value over the original. So pick some corresponding sides. Let's say I pick 5 inches. What corresponds to 5 inches in the enlargement? 20. So now let's set up the proportion, or the ratio actually. What's my new value? Yeah, we're going in this direction. This is new, and this is original. So we want 20 over 5. Simplifies to 4. The scale factor is 4. It basically, it's 4 times larger. Okay. Any questions? All right. Oh, this is called shadow casting, guys. Kaylee, can you read that for us, please? Number 5.
Okay. A tree casts a shadow that is 9 feet long. At the same time, a person is standing nearby casts a shadow that is 3 feet long. If the person is 5.5 feet tall, how tall is the tree?
Okay, so this is a way to measure things and find something that's unknown, known from unknowns, or unknown from a known, I should say. Okay, so let's make a quick drawing of what we have here. We have a tree. Okay, and this tree casts a shadow. And we have a person. And he casts a shadow. Okay? And we know some things. Let's see, what do we know? Do we know the shadow for either of them? Yeah, we know the shadow for the person, for the tree rather. It's 9 feet. Do we know anything about the person? He's 5.5 feet. And he also casts a shadow that's 3 feet. Okay? And it says, how tall is the tree? How tall is the tree? So this is our x. This is our unknown. But these are similar figures because what they make are similar triangles. This actually makes similar triangles if you think about it. Okay? So let's set up a proportion. What kind of proportion would help us figure this out? X over what? X over 9. We can do x over 9 equals, if we're doing x over 9, what do we have to have over here? 5.5 over 3. There you go. So try that. Basically, we did this and this. Go ahead and solve it, guys. This and this. Let's figure out what we get for x. Hopefully you got x equals 16.5 feet. Got it? Okay. So that's called shadow casting. All right. The next one says a map of the state of Texas shows the scale to be 1 inch equals 80 miles. 1 inch equals 80 miles. Okay. The distance between Austin and Corpus Christi. Ooh. I have done that trip from Austin to Corpus Christi. Is 232 miles. How far apart will the two cities be on the map? How far apart will the two cities be on the map? Okay, so they give us a proportion. 1 inch equals 80 miles. Okay? Then it says Austin to Corpus Christi is 232. Do we put it in the numerator or denominator? It goes in the denominator because they're giving us miles. And what we don't know is how many inches. There's the proportion we would set up there. So let's figure that out. How many inches would that give us? 2.9, is that?
2.9.
Okay. All right, let's try this one. Susie walks 1.5 miles to school. When she looks at the map, it shows the scale to be 1 centimeter is 0.5 miles. 1 centimeter, 0.5 miles. What is the distance between Susie's house and her school on the map? Okay. So it's pretty much what we just did. So I'd like you to try this one. So let me give you what the assignment is. One of these sheets again. Bring it tomorrow, please. Huh? 5 minutes here. Hmm? I know.
No, go ahead.
Yeah, turn it. Yeah, I know it's not.
How dare you get the money tree?
Oh, you're still recording?
I know. I have to edit it at the end. I see what you were saying.